Hello, everybody. I hope you're not too hungover, because we'll be doing some live coding today. So, I should probably introduce myself as well. Hello, I'm Lea. I hope this makes sense. Oh, wait. First of all, I guess I should have my slides up there. Anybody? Oh, OK. So, let's go again. Hello, everybody. I'm Lea. If you've ever heard my name before, it's probably due to one of my open source projects. Some of them are listed here. The rest are on GitHub. I'm an invited expert in the CSS working group, which mainly means that we gather 4 times a year, and we spend increasing amounts of time talking about issues, about edge cases of decreasing likelihood. And as my day-to-day job, sort of, I do human-computer interaction research at MIT. And I recently published a book. Actually, a lot of the material in this talk is also the secret number 14 in the book, if you're interested in reading more about it. So let's move on to something more interesting, like pie charts. So pie charts are everywhere. They're pretty ubiquitous. They're on XKCD. They're on Windows 95. They're on walls, on genitals, on food, on blackboards, and I'm pretty sure I don't have to convince you about how common they are on the web. You've seen them, you might have tried to make them, and you might have noticed that they're actually pretty difficult to make with CSS alone, or with web technologies in general. There are tons of frameworks about this very, very simple thing. Like, look at these extremely simple pie charts. It's just 1%, 2 solid colors, and still it's pretty tricky to make them with CSS. Try to take a moment there and think for a minute, how would you make them with CSS? How would you make a simple pie chart as simple as this with CSS? So I'm pretty sure you have a solution in mind if it's a very, very simple pie chart of like 25 multiples of 25%. You've probably done something like this in your life at some point. So let's and you can make it round with border radius, and rotate it with transforms. And that's pretty easy. However, most pie charts we need to make are not actually multiples of 25%, so I'm kind of trolling you there. So let's move on to something a bit more practical. Our first idea of creating custom angles might be to use a skewed pseudo-element, because that lets us do any custom angle we want. So let's give that a shot and see if it's a good idea. So the first step would be to make our element round and add a pseudo-element there. Create it with content empty string. Give it an absolute position. This is pretty much run-of-the-mill, right? Background so we can see what we're doing. And let's size it with something like, yep. And it's exceeding our element, so let's make overflow hidden. And now we have the basic structure that we need to start skewing. So you can see that we're sort of getting somewhere, but it's not actually centered, which doesn't make for a good pie chart, does it? So let's set the transform origin to the bottom left corner. And now it's at least sort of on the right place, but we still need to flip it. So let's give it a scale transform of -1, and now it's sort of growing in the right direction, but now it is. And we need to rotate it as well. And now we sort of got a pie chart, and it works until we get up to about this point. So that's not very good. but we can increase its size. And setting just padding instead of the explicit dimensions help us maintain a square shape, so we don't have to worry about which dimension is bigger. So now it still works, but only up to a certain point. Now it starts breaking again. So let's increase it even more. And as you can see, now it starts breaking again, and we can still fix it. But it's kind of a messy solution. Like, we have to keep adding numbers there, and once we get to 90 degrees, no matter what numbers we add, no matter how huge we make this, it won't work. Because think about it, you have a skewed element that is skewed by 90 degrees. It will just be a flat line. But still, we can sort of use this if we really want to. We could still make a pie chart that way, and we could flip the colors. If we wanted to have a pie chart that is over half, we could just flip the colors and it would work. But still, it's not good enough. And we might try this at first, and we might think, hey, we did make a pie chart with CSS. We managed to write CSS for pretty much any percentage, because, like I said, we can flip the colors. So there, we solved it. It's good to go. Let's add it to our website and move on to other things. But pure CSS, like making something with pure CSS is often good enough. I see many pure CSS demos. Oh, I made this with pure CSS. It's so cool. But actually, it's code that you would never want to deal with. You would want to like spit it out and then move on and never have to look at it again, because it's just really difficult to maintain. It's difficult to change anything. So it's not just about being able to do something. It's being able to do it well. So I think a good CSS solution needs 3 parts. And the proportions here are completely approximate and completely based on my own opinion. But I think a good CSS solution needs to be, first of all, flexible, extensible, and maintainable. What does flexible mean? Flexible means that we need to be able to change it, to change aspects of it, to change several aspects of it. For example, in the pie charts case, it might be the colors. Obviously, we might need different pie charts with different colors. Or the percentage. We will definitely need to show different percentages. And it's not just about being possible to change it. It also means, can we change it inline? Because that way we can make JavaScript components, and we can have like an HTML attribute and have JavaScript that picks it up and feeds it into an inline style. And also, how many edits do we need to change to make things? The more edits we need to change, the less good our solution. This is, in software engineering, this is called dry code. It stands for don't repeat yourself. The opposite is wet code, as in we write everything twice, or we enjoy typing. There's no consensus as to which is the right expansion of the acronym. Also, it needs to be extensible. And extensibility is very similar to flexibility. And in this sense, I mean how possible it is to make it do things that we didn't plan for before. And the pie charts example, and this depends on the use case. In the pie charts, it could mean, could we have multiple segments? The pie chart we needed only had 1%, but what if we need to add more? Like in the pie chart I had a few slides ago. Here we need 2 segments. Or can we animate it? Can we have a pie chart that goes from 0 to 100% via an animation instead of statically? And we might potentially in the future want to have effects, like a gradient on the segments or a pattern or something, or even a background image. And also, maintainability, as in how much of a pain it will be for other developers or even our future self to deal with this code. If you write it and you feel dirty and you feel like you want to wash your hands afterwards and never look at it again, that's probably not very maintainable. So some of it is how much code there is. That's only a part of it, because there can be a lot of code that's understandable, but it is some of it. The more code, the more mental effort you need to devote to understanding it. Does it use extra elements? Because then we have to look at the HTML, modify the HTML. If we want to modify any changes, it kind of increases the complexity. And mainly, how straightforward is it? How can we look at, for example, in the pie charts, can we look at this code and figure out how to change something, how to where do I increase the percentage? What do I have to change? So as you can see, these three are kind of related to each other. So let's go back to the skewed pseudo-element example. Is it flexible? We can change the colors with one edit. If I want to change this to, say, yellow-green, I can just change it here. To change the size, I can make one edit. But if I want to change the value, I need to make 4 edits. So here, I have a second pie chart as well that shows what it takes to make the percentage over 50%. And as you can see, I had to override 3 declarations to change it. So in the worst case, in the simple case, you only need to change the skew angle, and that's just one edit. But in the general case, you might need to go above 50%, and then you will need to change the background here, you will need to change the background here, and you will need to remove the scale transform and change the skewing percentage. So that's 4 edits, and it's kind of messy. It's also not possible to set the value in line. Since there's a lot of code that we need to change in the pseudo-element itself, we can't change that in line. We can't set pseudo-elements in line. We could use document style sheets and go over the CSS code and modify the rules, but it's just horrible. So let's just say we can't actually set the value in line. Is it extensible? Well, you could sort of have children instead of pseudo-elements and have multiple segments via that. So you could sort of make it even more hacky to have multiple segments. It's not pretty, but it will work. It's possible to animate, but it's painful. And actually, the reason I'm not showing you the animation is that it crashed Chrome. When it went from skew 90 degrees to, at some point when it went over 50%, it crashed, and it crashed twice, and I'd rather not crash Chrome right now. And some effects are possible, like you could have a gradient on the segment. It will be a skewed gradient. It won't look very pretty, but meh. And I'm pretty sure you can already see that it's not very maintainable. Like, I would not want to hand this in to another developer. I would feel embarrassed. Like, it's so hacky. It's a lot of code to do a simple thing. But hey, we have no extra elements, so there's that. So overall, it's not a very good technique. But it was the first one I thought of when I wondered how can I make pie charts with CSS, so I thought it merited showing. Now let's move on to another idea. So when we think how can we make custom angles with CSS, like any angle, and show it in a pie chart, skew transforms might be the first that come to mind. Then we start thinking about how can we exploit rotations, how can we unveil something and progressively show parts of it. So the trick here is to first color our circle with both half of the circle pink, well, magenta, and the other half of our circle as, well, actually, I should show you how this works. The other half of our circle with the other color. And actually, this doesn't have to be exactly the same as the previous color stop. It can be anything as long as it's equal or smaller. So I usually prefer to set it to 0, just so I can, if I wanted, I could modify this. And let's make it horizontal. And so let's style our pseudo-element now. Let's give it a margin left of 50%. I'll give it a random color so I can see what I'm doing, but I'll change it soon. Oh, so we need to make it a semicircle. So we'll use border radius for that. But we can't just use border radius 50% because then it will be an ellipse. So we'll have to use the expanded border radius syntax, which means different horizontal and vertical radii. So the top left corner will be 0. The top right corner will be 100% horizontally. The bottom right corner will be also 100%, and the bottom left corner will be 0. And then vertically, we want it to be 50%. So there's our semicircle. And if I make this gold, well, actually, if I make this magenta, then I can start rotating it. And as you will see, I'm already getting somewhere. Of course, I need to set the transform origin to about this point. So, and I already have a pie chart. And if you find it a bit confusing, I can add a dashed outline to show you what's going on. So there our pseudo-element is uncovering this half of the circle. And, OK, let's hide this. Of course, we'll start having issues again above 50%, but we can fix them more easily, as you can see. So before we do that, let's improve this code a little bit. First off, we need to convert our percentage to degrees, which is easy. It's pretty straightforward, but we can do better. We can use the turn unit, which corresponds very much more directly to our percentage. This is 10%, this is 20%, this is 30%, this is 50%. It's just our percentage divided by 10. Also, we had to duplicate our color twice, which is bad flexibility. It's not very dry. We have to make 2 edits to change this magenta to something else. But thankfully, we don't need that repetition, because we can just use background color instead of background and inherit it. So now we're inheriting it from the main element. And why did I use background color instead of background? Because we don't just have a color, we have a gradient as well. So if I used background, I would inherit the entire gradient. That would just be weird. Also, am I repeating anything else here? I'm not, but I have to change a gradient every time I want to change this color, which is not great. I would much rather set a single CSS property and not have to change the entire gradient every time I want to change the color. So what can I do? Since I don't have any text here, I can use the color property, set it to gold, and then use current color in here, which always refers to the value of the color property. So I can just change the color property, and my gradient updates. So I promised I would also show you what to do above 50%. So here I have 2 pies. This one just has a class of pi. This one has a class of pi and over half. So let's add 2 rules and see if we actually need to override both of them. But let's add them just in case. So what do we need to do here if we want to have a percentage that is bigger than 50%? Let's add an outline to our element again to remind you what it's doing. And as we change this, our element changes. So essentially what we need to do is we need this slice to be gold. So actually, we don't even, as long as we change the color here, or not even actually, I can just override the background here to current color instead of inherit. And we already have a pie chart that's above 50%. I don't even need to override this. And let's remove the outline, because we don't need it anymore. So as you can see, now I can have any angle I want. There is 60%, there is 70%, 30%. This would be 90%. Of course, I will need, the rotation needs to be like my percentage minus 0.5 turns. So, can I animate this? Sorry. Can I animate this from 0 to 100%? Let's try to do that. We will obviously need an animation for the rotation. which will go from 0 to 0.5 turns twice. But I only need to define one of them in my animation. I will just run it twice. And I also need to define another animation for the color, which will go from background color inherit to background color current color. And let's try it. So the spinning animation, let's make it 1 second. Spin, infinite. Let's have it repeat infinitely. And we don't want it to accelerate, so we'll make it progress linearly. So as you can see, it's already moving from 0 to 50%. And the bottom one is moving from 50% to 100%. But we need to combine them both. So let's add the other animation. And the other animation, actually, I should show them separately first. So the other animation will be, let's give it 1 second. What did I name it? Color. So if I make it also linear, you can see that it's kind of smoothly transitioning from the gold to the magenta, which I didn't want. I wanted to go abruptly from one to the other, because I wanted to change at the 50% point. So I will use step end, which does exactly this. It changes it in one step. Yeah, and I need to make this to happen in the at 50%, not at the end. Otherwise, it never happens. So let's combine them. So this will need to run twice during the progression of the animation. So they will need to have different durations. So the color one will be 2 seconds, and the other one will be 1 second. And there it is. It goes from 0 to 100. So you might be thinking, well, that's nice if I want to make a progress timer, but I didn't want to make a progress indicator or anything. I wanted a static pie chart. How can I use this to make a pie chart component pretty easily? So we can use something that is called static interpolation. And yes, it sounds kind of scary, but it's not really that scary. Interpolation is just when you have two values, a start and an end value, how do you calculate the points in between? This is what your browser does every time you do an animation or a transition. You specify a starting point and an ending point, and the browser needs to interpolate between them to find the intermediate frames. And I call it static because it's not actually an animation. So you'll see what I mean in a bit. But don't let the name scare you. So this is I find that this is a rather common case. I have 5 divs. I want the first one to be magenta. I want the last one to be gold. And I want to be able to access the spectrum between magenta and gold. And the browser knows how to do this because I can animate. I can write a keyframes animation and have it go to background gold. And I can assign it to the browser. And the browser knows what to do. The browser knows how to go from magenta to gold, and it could figure out all the values in between. But I didn't want an animation. I wanted to be able to access that spectrum statically. I wanted to give my second div, which has a class of P25, I wanted my second div to be 25% between magenta and gold. I wanted this one to be halfway between them. I wanted this one to be 75% between them and be closer to gold. So how can I do that? How can I take advantage of the browser's native interpolation algorithm? Can I run an animation statically in a way? So there is a slightly hacky way to do this, as you might have figured out already. I can use animation play state. So let me enable this again. Paused, to pause the animation. And you can see that I can actually pause it at any point, and it's actually applied there. And then I can use a negative. Oops. Let's make this smaller. Then we can use a negative animation delay of, say, minus 0.5 seconds. And you can see that I'm already getting there. And it's static, it's not animating or anything. And I should probably give this a duration that's more manageable, so that this will be 25. And then it's pretty straightforward how to do the rules for every other div. So there you go, we're already accessing what the browser is doing in its animation statically. We can even use it to debug animations. Like if I start from 1 and then I keep changing this, I can go through my entire animation in my own pace. It needs to be negative, though. So, yeah, as you can see, I can go through my entire animation in my own pace, step back if I want to, and I can basically statically run my animation. Because otherwise, sometimes when we're trying to debug animations, it's like, what's happening there? I need to make it slower, and then you end up waiting for like 50 seconds for the entire animation to run to figure out what's happening, because if it's 1 second that it normally is, you can't figure out what's wrong with it. So that way, you can just step through, kind of like what a debugger does to JavaScript. And it doesn't just have to be about a single property. If I wanted to animate border radius as well, for instance, I can just add that. And now I'm interpolating through that as well. So you might be wondering, why did I not add a P100 rule to style this one? So that one is a little tricky. If I do minus 100, it goes back to magenta. I could, of course, do something like this, but it's kind of ugly. So how can I do minus 100? Because this might be generated by script. This could be inline styles. I wouldn't want in my JavaScript to say, is it 100? If it's 100, convert it to 99.999. This is just bad code. So how can I fix this? I can change my animation. I can remove it, the infinite repetition, because I don't need it to be infinitely repeated now. I'm only stepping through statically. It doesn't matter if it's repeated or not. And then I can use forwards, which basically means that when my animation is finished, I want it to be stuck in the last frame. I don't want it to go back to the first frame, which is what CSS animations usually do. So yeah, there we managed to apply every single keyframe to each individual div. So this was a simple example. How can we use this for our pie chart? You might be already sort of seeing where this is going. Here we have the pie chart animation. And we can do exactly the same thing. I will just show you on this individual pie chart. I'll just use animation play state paused again to pause it. And a negative animation delay. I should change this to something more reasonable. And yeah. And let's delete and reapply this. So, but this is 5%, so actually this should be 100 and this should be 50. So yeah, this is 10%, 20%, minus 30%, 40%, 50%, and so on. But you might be thinking, well, there's this animation delay that is inside a pseudo-element, so how can I apply it via JavaScript? It's still in a pseudo-element. It might be one property that I need to change, but it's inside a pseudo-element. Oh, actually, I should fix the 100, because now it does this. So let's do forwards, and forwards here as well. And, that's not right. Well, what the hell? What? I can't hear you. Oh. Where? Anyway, let's not spend time debugging this. Let's bring it back to its original state that worked, and let's just pretend that the 100% problem isn't there. I know that it works because I tried it earlier, but you know, live demos, they always break in unexpected ways. So you might be thinking, this animation delay is inside a pseudo-element. So how do I fix that? How do I set this, the animation delay via inline JavaScript, via an inline style, since we can't set pseudo-elements with inline styles? So the thing is, because we don't need an animation on the main rule, which was not the case with the skewed transform, by the way, you needed an animation on both of them. But here, we don't need an animation on the main rule, just on the pseudo-element. So if I use animation delay here, it does nothing. It breaks absolutely nothing, because there's no animation for it to apply to. So I can just go here, and instead of specifying a value, just inheriting it from the parent. And then I can just change the percentage here. So that's actually a pretty useful trick for many things. If you need to change a pseudo-element via an inline style, sometimes you can think of a property that won't do anything on the parent and then inheriting it. Like, for example, color is another case. Like if I do current color on the pseudo-element, it's still the same. So I can change the color on the main element, and then I can use it in the pseudo-element via current color. So, is this a good CSS? Is this a good solution? How many think that this is a good solution? How many think that this is a bad solution? Not being daring enough to raise your hand? So, it's definitely better than the previous one. I think we can agree on that. We can change the colors with one edit, just like previously. 2 edits to change the size, because here, if we do it via padding, it's more complicated. Only 1 edit to change value, because we can use animation delay. So we can just change animation delay. And it is possible to set the value inline, because we just set an inline style of animation delay. Is it extensible? Well, we can't do multiple values due to the way of like having a rotated pseudo-element and having it uncover. Like maybe we can sort of hack it, but it's not straightforward how we could do multiple values. It's a whole different problem that we need to solve. I don't like saying that things are not possible, but it's definitely not possible in an obvious way. Is it possible to animate? Well, we know that already. And can we color the segment? Can we use gradients or patterns instead of colors, or can we do other kinds of effects? Not really. Also, well, it's not using any extra elements. The code is pretty much as we have as much code as the previous example. It's just somewhat less hacky. So overall, it's not terrible, but it's not great either. It's sort of okay-ish. So what else could we do? We've kind of exhausted all our ideas about CSS transforms and pseudo-elements and all that. What could we do? Is this the only way we could do pie charts? Of course not, because we have SVG. So most people that know a little bit about SVG, if you tell them about making pie charts with SVG, they will probably think of something like this. Very little CSS and an SVG with a path element, with a very cryptic path syntax. And I can tell you what this path syntax does, but that won't make it any more straightforward. It first moves to the point of 50% horizontally and 0 vertically, which is this point. Then it draws an arc to this point, over here that has a radius of 50. And if you see this 40, 80, this is the coordinates of this point. How do we find the coordinates of this point when we just have an angle and a radius? Well, trigonometry. Yeah, I wouldn't like to do that either. But that's how we calculate it. And how do we animate this? Yeah, tough luck. Which is why most people end up thinking of other ways to do pie charts and don't use SVG paths. However, SVG has many more tools than paths, as we will see here. So this is an SVG, an inline SVG element with just a circle. You might be wondering why the 64. So the viewbox attribute sets a coordinate system in the SVG. We don't use pixels or ems, or we can, but we don't use pixels or ems or stuff like that in the SVG. We set the coordinate system and we use the units of that. And then we can size the SVG with any CSS size we want, but we size the entire element. So I've used 64, and you will see why shortly, but I won't spoil it. So let's style the circle first. Because we can just style, these are just elements. They're inside our page. We can style them with CSS. Of course, SVG has its own CSS properties, such as stroke, which you set to a color. Let's set it to gold, actually. And stroke width, not border, which you can set to a number. Remember, it's numbers, not units. And these numbers refer to the coordinate system we specified by the viewbox attribute. So if we increase this number enough that it covers our entire circle and we don't see anything in the middle, there it is, 32. Why is it 32? Because our coordinate system is, the whole width is 64. So there's where the cool stuff begins, because there's this awesome CSS property called stroke dash array. And what it does, what it lets us do, the reason it was designed is so that we can have dashed strokes in SVG. So we can specify a number and a gap width. If the second number is the gap width, actually we can even specify more numbers if we so want, but usually they're not that useful. If we want to have like borders that look like Morse code. So this is the gap size, and this is the dash size. And it looks a bit more reasonable when I just have a normal border. You see it's just a dashed, a normal stroke. You see it's just a dashed stroke, pretty run-of-the-mill. But if I change my stroke to be the entire circle, then it creates many more interesting shapes. I mean, even outside of pie charts, I think this is a pretty cool shape. You can use it to make a starburst. Like if I set the fill of the circle to none, I just get the stroke, and I can use it as like a starburst background, which used to be pretty common on the web a few years ago. But here we're not making starbursts, we're making pie charts. So we want to use the dashed size to be our segment, and the gap width to be the rest of it. So we want to increase the gap width enough to occupy the entire circle. So we can either do this by fiddling with numbers, or we can calculate it. What will be the gap width we need? It will be the perimeter of the circle. What's the perimeter of the circle? 2 times pi multiplied by the radius. And what's the radius? 25% of 64, as you can see here. So let's use Spotlight to do this. 25% multiplied by 64 is 16. So 16 times 2 times pi is 100. So there's why our coordinate system was 64, because I want the perimeter of the circle to be 100. Because that way, our dash size corresponds to the percentage we want. So as you can see, I'm increasing this enough to go up to 100. No problems with what happens if it's above 50%, what happens when it's 100, how do I hack this? Nothing. You just set a property, and it's done, and it's exactly your percentage. You don't even have to do any calculations on it. OK, now let's style it a little bit more like a pie chart. Let's give it a background of the magenta color that I love so much. Border radius, because remember, even though we can't apply properties like this inside the SVG element is still an HTML element as well. So any CSS that applies on HTML elements applies on the inline SVG element. So we're pretty much done. We also need to transform it via, not exactly. Yeah, why did I scale it? I don't need to. Do I? Yeah, I don't need to. It's just a rotation. So there. And that's exactly the pie chart we struggled so much to make with the previous techniques. And of course, can I animate it? Let's try that. There. No. Thank you. No complicated hacks or anything. Who said SVG was that hard? It seems much more straightforward to me than any of the CSS solutions we tried. So, can we have multiple segments with the SVG solution? Of course. We could just have multiple circles with different dash array values. So here, I've made a pie chart of the composition of the CSS working group. You can see I have 2 circles. I've set the styles inline, so I can just show you the entire example in one bit of code. So I've set stroke dash array and the stroke color inline. You can also use the style attribute, but in SVG, properties are also attributes. So there's this weird thing. But you don't have to deal with it if you don't want to. You can just use style equals whatever. And here, you might notice that there's a slight complication. I had to do it in a cumulative way. Like the percentage for invited experts, even though it's 8%, actually, I had to specify 13. There is a way to get around that and actually specify 8 if you also use stroke dash offset, which lets you offset the dash. But I preferred to do it that way for this example. But just keep in mind that if you really want to use the exact percentage there, not a cumulative percentage, you can use dash offset. So yeah, I can have as many segments as I want. And you can also see, completely unrelated to the talk, but you can also see in this example how, even though we think that standards are made by W3C, actually, it's all member companies. 83% of the working group is member companies, so it's essentially browsers making the specs and not W3C. Poor W3C has a very little say in it. So, how good is this technique? There's only one edit to change the colors, 2 edits to change the size, 1 edit to change the value, and a pretty straightforward one. Yay. Of course, we can set the value inline. We just set stroke dash array inline. We can have multiple values. I just showed you how. We can animate it. You've just seen how. We can have effects because there are SVG gradients that we can use, SVG patterns. It's super messy, but it's possible. We need extra elements. That's one problem, but you can use like a div with an attribute and then pick it up with JavaScript and add like an SVG element with a circle inside it. It's not that much code. It's like maybe 5-6 lines of JavaScript. Maybe a little bit more because you have to deal with horrible namespaces, but it's not that much JavaScript. And it's pretty straightforward, I think. So yay for SVG stroke dash array. Is there a better way? Well, so there's this thing called conic gradients. And, whoops, sorry. And this is essentially what it does. You can see what happens if I add more stops. It's called conical gradients because it looks like a cone if I add the right color stops. You might have heard them as angle gradients. Photoshop calls them angle gradients. And there's so many cool things I can make with them. Like, I can make a hue wheel with them, like this. Blue and fuchsia and red. And I can add a border radius. There's a hue wheel, which you can use if you ever make a color picker. Thank you. You can make a checkerboard. How? You will see. So, actually, there. And how do I make a pie chart? That should be pretty obvious now. There's one pie chart. How do I add more segments to the pie chart? Well, there's how I add more segments to the pie chart. So, how awesome is that? It's defined in CSS images level 4. There's the spec. It's pretty awesome. One edit to change anything. The colors, the size, the value, you can set it in line. You can have multiple values. It's super easy to animate, obviously. Some effects are possible. That's kind of tricky, though. No extra elements needed, only 3 declarations. That beats pretty much every solution we've shown so far. It's very straightforward, I think. It's pretty awesome. That applause was for conic gradients. There's one little problem, though. Just a tiny, tiny little problem. Yeah. Yeah. I know. So, the good thing about it is that browsers prioritize what to add based on what developers request. And since there's already a specification on it, it's pretty much on you guys now. Tweet to browsers, blog about it, add bug reports to browsers, request it. You don't realize how much power you guys have. The more you request something, the more browsers will prioritize it. Because they can't implement everything, so when they decide what to implement, that's how they decide. What have been developers pestering us for? What have they been blaming us that we don't have? What do they need? And that's how they decide what to implement. So, if you want conical gradients to be implemented, and I think they're pretty awesome, ask for them. You'd be surprised at how far that can get you. So, after we've spent pretty much 50 minutes discussing how to make pie charts, are they actually a good idea? So, how many of you have heard of Edward Tufte, the information visualization expert? Some of you. So, he has very strong opinions, and he has very strong opinions about pie charts, too. He said in one of his books, a table is nearly always better than a dumb pie chart. The only worse design than a pie chart is several of them. For then the viewer is asked to compare quantities located in spatial disarray both within and between pies. Given their low data density and failure to order numbers along a visual dimension, pie charts should never be used. So, he does have a point. Look at this pie chart. Which segment is bigger? Which segment is smaller? Can you order them? It's kind of a trick question, because they're all the same. but it's kind of hard to say that with confidence, isn't it? What about this one? Can you order them by size? Can you compare them with the previous pie chart? It's kind of difficult, isn't it? It's much easier if you're looking at a bar chart. So yes, Taft does have a point, although there are cases where pie charts can be good. He's a bit too absolute. Like if the numbers are vastly different and you just want to show the general trend and you want to compare something to the whole, then pie charts can often be a good solution. And if everything else is equal, if you have to choose between a pie chart and another visualization, and they can both display the information in an equally informative way, which, like I said, depends on your data, pie charts can often be a better choice just because, actually, there's research that humans prefer round shapes, as completely irrational as it sounds. Humans are irrational. It's how our brains think. We like round shapes. So, I've just spent an entire talk talking about pie charts, and now I'm telling you that maybe, in many cases, they're not a good idea. However, as you should know by now, after all of this, this talk never really was about pie charts, was it? Thank you very much. So I think we have 8 minutes something for questions.
I think for me, at least, I think for other people here as well, it might take hours of Googling just to apply any one of those solutions to the, pie chart problem.
Mm-hmm.
What would you recommend? What's the path of least resistance when we're facing problems like this in design of our web elements?
I think the most important bit is to not stop easily. Like the first solution you come up with is almost never the best one. Like, try to think about the aspects I said. Is it flexible? Is it extensible? Is it maintainable? Evaluate it. Is it a good solution? Can I improve it? Can I reduce repetition? I have to repeat this thing twice here. Can I remove this duplication somehow? So the more you think about it, it's kind of like solving a mathematical problem. It's pretty much the same thought process. Like, you first come up with an idea, you try it, it doesn't work, or it does, but it's not a very good idea, and you try to refine it and make it more elegant. There's really no magic to it. As long as, obviously, you need to know what's available, but apart from that, as long as you keep prodding and trying and thinking and not giving up, I think that's the most important bit.
Except for the spec, which is I think, a little hard to read for most people.
Yeah, I think...
Where can you find all that? Some of the stuff that you demoed was...
I like MDN as a resource. The specs can be varying levels of readable. Some of them are readable, others are not. I think it's worth it to take a look, see if it makes sense. If it doesn't, look somewhere else. And don't feel bad, because sometimes they don't even make sense to CSS working group people. There is, but I'm trying to avoid the shameless self-promotion. But there is, yes, I have an entire chapter on pie charts in my book. It's secret number 14, I believe. It's called Simple Pie Charts. And actually, after I wrote it, I thought that, hey, I really like this. I should make a whole talk about it.
Hi, Lea.
Mm-hmm.
Hi, here.
Where?
Here.
Oh.
So I assume your presentation was browser-based?
It was what?
Browser-based? It was done.
Yes, it was. It was. My slide has gone away. Can we put up my screen again? Because there was a link to... Yeah. So the slideshow framework I used is the one I wrote a few years ago. It's called CSS. I usually publish my slides, but because this is a very new talk, I haven't done so yet. Honestly, because I'm kind of embarrassed about the code. I just quickly hacked it together, finished it last night. So it's kind of embarrassing. But they will be posted pretty soon, like maybe in the next week or so. So if you check Twitter from time to time, I'll definitely publish them there.
All right, that's not the question I had.
What?
That was just the assumption. The question is, the last example, Conic gradients.
Sure.
How in our world did you do that if
Oh,
browsers don't
yes.
support it?
So, yeah, I wrote a polyfill, which I plan to also release. There are some examples. But even though it works for my slides, it still needs a little more work to make it usable in like a real use case. Essentially, the way it works is it parses your syntax, it makes the gradient in canvas, and then it feeds it into a data URL. It replaces your conical gradient. It uses prefix free for the polyfill, and it replaces your conical gradient with a data URI. I think I can actually show you because it's inline. So, yeah, you can see what's going on here. My conical gradient is actually replaced with a data URI behind the scenes. Mainly, the main reason it's not ready for being released yet is sizing. Like right now, it's a fixed size of 400 pixels, or any size you can specify, but the problem is there's no way to know what size the element is, so I'll need to figure out some kind of solution for sizing. But it works great for my talk, because I know what size my conical gradient is here.
Lea?
Yep.
Here?
Ah.
Hi. I'd like to hear your thoughts about SAS and LESS and other compilers.
I use them sometimes. I try to avoid using them by default. I usually start a project and soon it becomes pretty obvious whether I will actually need one. Like you see your CSS like starting to become kind of difficult to maintain, like if you have a lot of repetition. But I try not to depend on them too much because eventually my vision is that at some point these will not be needed, that CSS will adopt these features natively and we will not need preprocessors. And there's already standardization work on that. Like there's a proposal for nested CSS rules. The syntax might be a little more awkward than preprocessors. Not too much, but a little more awkward because there are parsing challenges involved. Also, there are CSS variables. They're only supported by Firefox at the time, but you know how this goes. Eventually, it will be supported everywhere. They have a different syntax than SAS variables. They're basically custom properties that you can reference their values, which can be actually very powerful. Because in SAS, variables are lexically scoped. If you want to use them in a different rule that is completely outside where they were defined, you can't. But in CSS, they just inherit like regular properties. So you can just define them on a root element and then reference that variable, and it will just get the value of the variable depending on whatever you said. It's very dynamic, and you can change the variable with JavaScript, and it updates dynamically, so you can do all sorts of cool things that you can't do with preprocessors. And also, it's the same route with calc. Like in the past, we needed preprocessors to do calculations, and now we have calc, and we can use calc for calculations, and it's much more powerful because it's dynamic. A preprocessor doesn't know what 100% corresponds to because it needs to process your CSS before it reaches a browser. So how could it possibly know what the percentages refer to? But your browser does. So so calc is way more powerful than doing calculations in preprocessors. And it's pretty much the same with any of these features. Once CSS adopts it, it might be a bit more awkward. The syntax might be a bit more awkward, but it's usually a much more powerful, much more dynamic feature. So I try to avoid depending on them because if I do, I might end up I'm worried that, you know these people that they learned to write JavaScript only via jQuery, and even though we don't need jQuery as much today, they're kind of grown so dependent on it that they just can't let it go. That's what I'm worried about with preprocessors, and I try to write some CSS without them when I can. Oops, time's up. But I guess maybe we have time for more questions, do we?
Last question?
Okay.
Last question.
Hey, so this is more about the CSS working group.
Uh-huh.
So one of the main things that I'm seeing that most developers are struggling with, and I feel like a lot of the hackier solutions revolve around, or there are most dependencies around pre-processing, is scoping. The whole issue of CSS scoping, and I know we have, when using the Shadow DOM, we have the scope properties, and it's a bit cleaner. I wanted to know if there is any work or progress on providing better solution for CSS scoping.
Yeah. There were some discussions a while ago, but I don't recall, there was a meeting like 2 weeks ago, and I don't recall any discussion about it. As I'm sure you know, the Shadow DOM combinator was removed, so there's that. So I'm afraid not much right now. Sorry.